Hello, ladies and gentlemen. What's up? Oh, center like that. There we go. I got some pretty, cool stuff I want to show everybody. And it takes a lot to make it happen. But I have a buddy of mine that says I can make it happen without all that. And that's pretty awesome. So we'll see what happens. First, I'm going to show you what I discovered by combining a solid state device and a pulse motor and pulsing the pickup coil from two different directions with two different waves at the same time. Makes some like pile driving readings. It's pretty awesome. Okay, so that is, this power supply goes to the bottom coil of the solid state. This power supply goes to the wheel, one of the dual drives in the wheel. That's a 12 volt system, so we'll put 12 volts in.
What kind of question do you want me to ask?
Solid state generator or pulse motor generator? Because this is the combination of both. So we're taking a look at our sine wave here. Make sure you're getting all this. Can't really see that. Maybe if I move the whole thing up a little bit. Hello, hello. All right. So we got the two power supplies on so far. And then we're gonna try and eliminate, some of the usage here. We got our signal generator. We're going to turn that power supply on now. So now we're 12 volts deep, okay? And we haven't touched the battery yet. We're outputting on the batteries. Both of these batteries are being charged when the wheel is running the dual drive. All right, so I'm gonna start it up now, and we're gonna see a little like sideways tornado, and we're gonna hear the core pounding. So here, let's. So we got the wheel and it's operational. Look at our wave that's starting to form. Just the bottom coil is being pulsed right now. When I say the bottom coil, I mean this coil down here, and there's a coil in the middle, and you got your top coil that's pulsing downward. If you're looking at it, north is up, then north is facing downward with the way it's set up. Once that gets going fast enough, it'll stop pounding. It'll be going fast enough that you won't hear it. All right, so I'm gonna throw on the second coil. Go over there, okay? Good. on, man. Let's not mess around. Alright. So we got the... I love that cat. I'd like to call this the beat wave. I got it backwards in my shorts. I made a couple shorts and I called this the pulse wave, but it's the beat wave. And I called it the bass wave, but it's really the beat wave. It's how many like beats there are in a rotation. There's 3. 1, 2, 3. There's 3 magnets in the rotor. So that, I think that's significant based on it being on a normal, time. I think it says it's making about 700 peak-to-peak volts. No, 300. Okay, that's 300. Okay, now we're going to throw on the second coil. It's going to come down from the top. This little tiny white one right here is made out of Litz wire. It's 100 strands of 38. So let's hit it. Look at that. So what the Litz coil does is it makes a sine wave that goes straight across. So you get your bass wave or your pulse wave. And then you get your coil on the bottom, which is pulsing at a much slower rate. It's going at the rate of the magnets on the wheel. There's a trigger coil right here that's hooked to this coil on the bottom. So you don't necessarily have to get the magnetic induction to get, you get what I'm saying? You could either put it underneath, which I've done too. You could put this coil on the bottom, put this coil on top, the middle coil on top, have it underneath the wheel, and then a passing magnet will induce. And it induces right around the same amount. But you don't get that tornado effect with the induced. With it coming directly from the magnets itself. But it's quite a bit, it's like 50 volts, 50 AC volts. Just from magnetic induction is pretty good. But yeah, man, that's a dope wave right there. I'd say it's about 3.5, 4 on the beat. Which is good, which means it's going a little bit faster than, it's hard to explain. But the faster the wheel goes, the more of these humps you're going to see in the oscilloscope. So I'd say if there's 3 magnets and you got 3 humps, you're right on par. But you can make it so you've got 9 humps with 3 magnets. They'd be a little bit spaced out, but you can get it all in the same reading. You know what I'm saying? You just have to make it spin faster. Let's see what that would actually look like. I'm going to back it out a little bit, the oscilloscope. Make it all like a little smaller. Let's see if I remember how to do that. Okay. Yeah, there we go. Yeah. See? Look at that. That's pretty sweet. And that's like 12 of them, but that's like 3. Alright, there we go. Look at that. That's the two waves combined. That's a pretty good reading. Looks like we got about 800, between 800 and 920. Peak to peak. I know it can be better than that. I've seen it higher, you know, but it might be because of the way I have it set up with in the external way. You might actually get better readings if I just hooked it up underneath the wheel. And then there's another way to hook it up, which we're going to use the SSG from the K-Energy.store. We're going to see if we can't get it to oscillate. This coil right here. We're going to see if we can't get it to self-oscillate. And we're going to see if we can't get the similar reading. But we're going to not put it underneath the wheel. We're going to keep it away from the wheel, and we're going to try and just get an oscillation reading. And if we get an oscillation reading, we'll put it under the wheel and see if we can't get it to do what we got going on here. I'm going to let everything cool down real quick.
3055 transistor, you got it.
You know that Litz wire coil, the one on the top there, it draws about 800 milliamps just to run it. That's how much power is flowing through that little freaking thing, because there's 100 strands of parallel wire that is literally about 25 to 35 turns in length. It's tiny. It's a tiny little coil that's times 100 parallel. It's amazing. And you get the little twist in there. It just costs so much to use it as a generator, but it doesn't. It's not big enough or long enough in its entirety to use as a pickup coil. And there's no way I'm going in with my multimeter and doing 100 strands to hook it up individually strand-wise. I'm not doing that. Even if that's the way it has to be done, I'm not doing it. You know, it's all going to be clipped together with one clip, and that's as good as it's going to get. But I have a challenge. Maybe I can do it with solder. Maybe if I learn, the challenge would be I learn how to solder. And then maybe I can get more contact with that for a pickup purpose if I soldered the connection to it. And that's a hard maybe. You know, it's still 100 strands. You have to separate them enough to get the solder in between them, and there's still going to be at least 50 that aren't being touched. You know, you gotta take your time with that. But yeah, if I ever learned how to solder, that's probably the way I would do it. But until then, I'm just gonna clip it. And I tell myself all that stuff, man. It's like, dude, you are not, because I want to see what would happen if we actually hook up 100 strands of 38 in parallel. Literally. instead of just 1-2, bang, you're in. That would be such a surge of power, it wouldn't even be, and it's just, even though it's 38, so like the amps wouldn't be so high, but they would be really high. Because as you can see, just with it clipped the way it is, with the wire that's actually contacting, it literally requires about an amp to run. That tiny coil requires an amp to run. It's amazing. Alright, so I need to I got it in my pocket, sweet. So I believe this coil is 24 and 30. I might be doing this entirely not right. So I'm guessing that your drive strand and your trigger strand have to be the same length. Let me get the ohms reading. So you can't, like, if it's a trifilar, you have to leave the one trifilar just out of the equation completely. Or you're going to double up in length on one and not the other. So we're going to do the 24 and probably the 30 for the trigger. We're going to use my big old pot. I'm using those. I can't. I don't have anything to hook them up with. So I'm going to use my 25 watt 3/4 turn pot. And I'll just move it really, really slowly. Alright, I'm going to have to move my oscilloscope clips to this SSG real quick. Excuse me. And the pulse, the stuff I've been doing charges the cap bank with ease, man. It's smooth. So that's a comforting relief. Have everything working smoothly. Oh yeah. All right. Almost forgot. Sorry about that, folks. There we go. All right. So what I'm doing right now is I'm hooking up the SSG to oscillate. try and get a reading on that. Alright. It's cool, man. I can like figure out what wires are what based on touch. And be confident about it, like pretty much. Oh no. Alright, so
Alright, we got 27 votes.
nice, but who's winning?
I got both.
Nice.
It's 56%. Pulse motor 30. Solid state 15%.
Nice. That's amazing. Well, here we're going to do both. At the same time. But first, we're going to see about oscillating this coil. If we can get any kind of decent reading off of it.
So, yeah, it's like the wave signal generator is showing when in the resonant frequency range, the results amplify greatly.
That's right.
Is that, did the ferro liquid show that?
Yes.
Okay.
The ferroliquid showed like there were two there was one resonant frequency that was nearly double the first frequency. So there's like two humps, so to say. One smaller than the resonant one. One was at like 210, 220 hertz, and the other one was at like 470. Resonant frequency was at like 470, 444, 470. But it seemed like every time I moved it on the table or tried something different, and everything would change. So I'd have to find it again. But that's why I say 444, 470. I mean, if you change your environment, you change your circumstances, right? And I mean, it's just one of those. You can change a constant into a variable just by changing the rules a little bit. All right, So, how about we hook up one battery, one of these batteries to the output. Well, actually, I want to hook up this pot first. See, I'm stretched in right now. I'm out of clips, so I gotta cannibalize. But we gotta get. Yeah, that would work. Alright, we got the clips we need. We just need that. And about 15 more minutes. No, I'm kidding. We need about 2 more minutes. Maybe. Now, there are 4 slots. Do I put the resistor first? Or do I put the pot first? If we're going down from the transistor down to the logo, first I'm just going to do it. I'm going to do it the way I think it should be done. Probably going to be wrong because I'm not going to put the resistor in. I'm just going to use the pot. Second one. Now, clip. One end in the middle to these ends.
10 legs.
Nice. Alright, so we are clipped there. Now this needs to go to the ground. Alright. look at where it is right now. Oh, we're gonna turn it on a little bit. We want it all the way to the side, or we want it choking it a little bit when we turn it on? I don't know. Okay, so charge battery. We'll have to take a look at the other way after we test this a little bit, because I'm now cannibalizing it. It's all right though. Let's see here. I built it, so I'm gonna put it back together. Alright, so I don't know, I think we should put some resistance on this before I continue. What do you think?
Yeah.
Yeah?
You know me.
Alright, we'll put it up to about 450. And we'll go from there.
How's he best?
I think it's gonna be this one. Oh. So it looks like we have a small oscillation. So let's see here, volts. Zoom in on that a little bit. Oh. Okay. We'll back out. We'll look at the auto. We'll start playing with the pot, I guess. It's like we're way below the line.
Check it for deep too.
Yeah. I'm looking. There's nothing going on. See, now if there's a way to trip it, just to like trip the base one time. Or you said there was a special transistor I needed, right? Nah, dude, no. No, 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 no. Huh. That was interesting.
Just an M.P.H.
Alright. Well, then we're good there. Oh, look here. Hey. Woo! Look what we got here.
Yeah.
Square wave. Let's zoom in on this. Let's see what we can do with our. Oh, we are oscillating. Okay. All right. It's just let me look at our meter here. I think that's about 800 ohms. Or it was. Oh, okay. So it's very sensitive. So it looks like we got to auto adjust it each time the meter. We do the test here.
How much power runs to the coil?
12, it's 12 volts in and out. I'm not sure how much amps though, like can't even get a good reading on the coil. We're close though. We just had it like a second ago.
Yeah, let us know if you do get it.
Yeah. So that was pretty cool, man. I didn't see it as being, well, yeah, literally about 1K. The wave there was big. It was nice. It was a square wave though. Is that what it's supposed to be? Saw some action there, but I mean, that's good. I'm sorry I can't re-find it, but that's evidence enough for me to know that this is a thing, man. Thank you. I'm happy. That's what I'm trying to say. Okay.
You got this.
No, don't take a look.
Okay. Yeah. You know, I have this funny feeling that well, it shouldn't be draining any power from the battery if it's not running, correct? All right, I'm going to do this for about 3 more minutes. I already got what I wanted to see, so I'm good. And it's not the same. But it's pretty cool. So. Yeah, my scope is not good enough to pick up when it falls into resonance. So this isn't, I found a spot that was oscillating pretty awesomely. And then of course I thought I could hone in on it, and I moved it, and yeah, I moved it. You moved it, yeah, I moved it. it's only going to take me a little bit of time. But I am going to hook back up. Yep, so if you want to see, maybe I was in the way, I hope not, the oscillation of the coil, go back to almost the beginning of the stream and check it out. I did get it. I got it. But it didn't stay. I moved the potentiometer after the fact, and it did not stick around. And I couldn't find it again, so. Sure I've got, oh yeah, I need to hook this back up right there. I mean, there's a lot of things I gotta do. I can do them all on the fly, but I mean, I'll probably end up using a different coil than that one. This one is like 15 ohms for the strand I'm using, the 24 gauge strand, but it's a tri-filer coil, so if I hook the 30 gauge strand up in there, it's 50 ohms. But I didn't, I didn't hook it up in there. I used the 30 gauge strand as the trigger coil, or the filer, whatever you want to call it. So the frequency of the bottom coil here.
Yeah, he's got a jet.
All right, Yanni, I'll check you later, man. Thanks for coming by. I appreciate it. Thank you very much, Yanni, for teaching me about that oscillation.
And he said you did get it when it was there. You got it.
Yeah, I'm happy with that. I hope other people got to see that too, man, because it was just there for a few minutes, or maybe even just a minute, before I went and screwed it up. Alright, I'm just making sure, because I did dismantle some stuff here. Okay. Alright, we're going to turn on top coil power supply. So this Litz wire coil is going to pulse as soon as I turn the signal generator on. Turn this on. turn this on. And then this one has also got to be turned on. So I'm going to turn these on, and then I'm going to make sure the shot is good. Okay, everything's on. All the transistors are working. Yeah, it looks pretty good. Alright, we're going to start up the wheel first. And this is going to give us our frequency for the bottom coil. You can hear that iron core in there kind of pulsing. Oh, I didn't hook up the... Oh, man. I'm really out of it. Not really out of it. I'm okay. I just forgot to do something. That's what I mean. I gotta hook up the multimeter to the pickup coil, or we don't get any readings.
So iron core motor.
All right. I will check it out. Now we could hook all this up to the bridge rectifier and then send it into the cap bank and then just monitor how much electricity is being generated by how much the cap bank is going on. Could do that, but I think this is more fun. Alright. Let's try this again. So the magnetic strength is enough to just, at this speed, be having enough to trigger the transistor. Alright, so there's our wave that's starting to form. It's kind of like a sideways tornado. Alright, so that is the iron core that's thumping on the ground as as the electricity pulses through the coil. I would call it constriction, but not really. It's just an electrical pulse. But it can make your muscles contract, absolutely. So there it is, right here. There's three magnet nodes. There's 6 magnets, but there's 3 120 degrees. There it is. Each time the magnet passes over, you get like this reverse propagation almost. Or is it going the other way? Am I reading it backwards? But see, there it is. Now it's going fast enough that you can't hear it hitting anymore, or it's not grabbing the iron core like it used to. All right, but now here comes the fun part. Now we're going to hit the oscillation through the signal generator. And well, bam! Look at that. That is like, you can see that flux. Like, it's awesome. So this is a combination of a sine wave that would be going, you know, straight across like this. All right, I'm going to try and get a little bit closer with that. So that's awesome. That's literally 3.2 beats. It's 3 magnets, so I'm thinking that has something to do with it, but it's moving a little bit faster than it would be to synchronize with 3. So you get like 3 1/4, and a little bit less than that, 3 1/8 pulses of sine wave. 1, 2, 3, and a little bit. If it was right on par, it'd be 3, right there. But it doesn't matter. I think it's better to have more segments in your measure than less segments in your measure. As long as they all register to be the same amount of voltage, having more on that measure is going to be better, because that the nourishing effects on batteries that pulsing has is, I believe, something that people know about. The ability to revitalize batteries through solid state devices, through pulse motors, but basically through pulsing, you get, it's like you're talking to your battery, basically. So right now, this one, I think it's this one, is charging. This one is charging, this one is charging. This one over here, sure. It's charging this one over here. And I have a meter over there that I can hook up right now. We'll check it out. So 1227, this is charging. We're using one of the dual drives to spin the wheel to, you know, pulse the pulse, you know, create the beat. All right. Yeah, with the solid state stuff, you really got to worry about overheating. You got to turn it off every once in a while, man. You can't just leave it running. Something's going to overheat. Even if it's that's not directly involved with your experiment, something is taking a hit. Oh. Your batteries, I guess. There we go. There it is. See, it simmers down in there, and then that coil's still operational. So let me turn that one off. As soon as you turn it off, boom, silence. But yeah, I guess if you're using batteries and you're in a closed system because you're using batteries, and when I particularly think that a closed system should be one battery, not two. And I don't know if that's right, I don't know if that's possible, but in my mind that's what it is. And if that's not possible, then maybe it's not possible. But I've used one battery and this cap bank, and I've been able to hook up, you know, a loop, a literal loop that didn't interfere or do any damage to itself. But as in all closed loop systems as such, you have loss. There's loss. Loss is real. So, and now the power's off and it's still above 20, so that's awesome.
Gabby is back.
What's up, Yanni? Welcome back. We're just letting things cool off for a second.
Views.
Nice. Nice little cozy night.
Is it like a hose and water?
Is it like a hose?
Yeah, and water. What you're doing?
Maybe. I guess you could hook it up that way if you would put enough, if there was a strong enough field. You could use it to pump water, yeah.
Yeah, trying to fill the tank with the same hose.
I don't know, man.
I'm saying it verbatim. You're doing great.
Alright, that's awesome. Alright, what he said, yes, I don't know. I think it's a great idea. So what are we looking at? Let's turn it back on. Let's do it the other way this time. Let's do it with the pulse signal generator first. So this one, and it's strange, man, we're using 3 power supplies and not one of them's going above 12 volts. So, I mean, what's your maximum input? 12 volts? It's 12 volts, man, seriously. See, because if one of these goes up to 15, that's a whole nother ball game. It's a whole nother ball of wax. It's like, this is a 12 volt system. Alright, now all the power supplies are on. Alright, we're going to pulse signal generator at 406.7 hertz. Now let me mess with this for a second. 310 AC. There's our sine wave that goes all the way across, right? Now, let me start up the motor. You got your thump-a-lotta over there. see, there's like two ways in my mind that you can run this. You can either run it stacked up on the coil like it is now and have the trigger coil underneath the pulse motor, like it is right now. And you can get that extra thump. You can get maybe a few extra volts from the 20 gauge coil that you don't get from the magnetic induction. Or you can put the Litz coil that's on the stack on the bottom. You put the pickup coil and everything underneath the motor, and you get your pulse that way. Either way, it's pretty much the same thing, just a maybe slightly different amount of voltage. And that, I mean, when I saw yeah, dude, the oscillation of the SSG circuit is awesome. I might have to get the connections for the smaller pots and do the 10-turn pot with that. So the top, the coil on the bottom is being pulsed by the motor, so it has a totally different frequency and wave than the signal generator produced wave. And you can see that, but we're gonna do one more experiment for sure, where I've already done this experiment already, made a video about it. But we're going to look at the difference between the wave that's popping up now and the wave that's going to pop out when I put the coil underneath the rotor instead of having it out and being more complicated than it needs to be,
You ever heard of Brown's gas?
No.
Brown's gas to power motors.
Nice. Is that biodiesel? Or what is that?
It is from rosin smoke. Nice. That's amp.
Oh, okay.
My bad.
Alright, so let me set that up real quick. I'm gonna have to glue it because it is magnetic. It has a nice ferrite core in there. Alright. So we take this and we flip it up. I'm going to show you that this way is pretty much the same way as it is right now. So I am going to break down the circuit and put the dual drive back on. Because I'm not going to need it anymore. Alright, so we are hooked up underneath the wheel now. Make sure that's working. Do this first. I'm gonna take that transistor and I'm gonna put it back real quick because I know it's good. So. Alright, here we go. Let's see if the dual drive is hooked up again. We're good. Here's one, here's two. We got equal amp draws on both of those. And there's our, see, it's not the tornado one, it's a different wave. Okay, now we'll turn on the signal generator. See the difference? And that's awesome though. Now we have what looks like 6 segments, and then they might look like they're a little bigger. There we go. Yeah, 446. 444. We'll just make it all 4s.
Is the battery charging part auto after venting?
I'm not exactly sure how to answer that. Maybe. There's a diode. It's off the collector. I would say yes. But I'm not using any pre-made circuit right now. I mean, I do use them, but I'm not right now. So it's not a Bendini SSG by any means. It is far short of a Bendini SSG. Wow. Awesome. So let's do this since the signal generator is still on. One point two, 1.12, 1.11 K volts peak to peak. That's awesome. So I found that when the magnets are resting over the top of the pickup coil, there's a lot of magnetic interference, of course. And you don't get, that's when the reading gets choked. That's when you get your choke point, is when the magnet actually crosses over the core of the pickup coil. That's a pretty awesome dual drive, huh? There we go, there we go. Got this. I'm gonna work on that. I'm gonna get a coil that I actually want to use to do it, and I'm gonna clean up a little bit. We're gonna do something fresh. You might not use a wheel. You might just use a circuit kind of thing. Wow, that thing is whipping. 12 volts, 0.9 amps on both. Really, really cool. So if the magnet on phase ends up being your duty cycle, you can. It's got an 8-inch diameter. What you want to find is the circumference of your rotor. And then you want to find out exactly, using the proper unit of measurement. Like if it's inches, like if it's an inch magnet, you want to do 3 times 1. So you got your 3 inches. You want to subtract that, or you want to remove that from your total area on your circumference. So 3 magnets, and I think is like 26% duty cycle. Okay, so you don't want a 50% duty cycle with the little amount of magnets. It's all about how often your motor is on. So, it's not, it really isn't about how many magnets you have, it's about how big they are. Both of those things matter, but you're really just trying to find out how often your motor is going to be on for. So with 3 magnets, it's going to be on less than 50%. Not how many times it's going to be on for in a revolution. That's not what we're asking here. That's not what duty cycle is all about. It's about how long you're actually on, the motor is on for. So if the motor is only on when a magnet passes the coil, you got to know how big the coil is, for one. You got to know how many magnets there are, for 2. And I can't, since I wasn't taught like a proper way, I'm trying to explain what I know in my head to be right about the duty cycle. Because it's supposed to be how often the motor is on. So it's running all the time. It's on 26% of the time, it's off 74% of the time. So if you put that in your pulse, when you're doing, that's something we could probably do for a future live stream, is mess with the duty cycle. Like a spherical magnet would have a duty cycle of 50. Because you got one half of that is north, the other half is south. There's only 2 poles, and so on and so forth. But that would be a 50% duty cycle for sure.
Said you need a bigger magnet.
Where? Just anywhere? Yeah, I got some pretty big ones, man.
Yeah.
They're not the biggest ones. They're not like junkyard magnets, but they're pretty neat. All right, let's turn this on. This time we're going to watch the amps go. Okay, amps. So we're normally drawing like 0.9 amps parallel. So sometimes, you feel like you need to explain parallel and series, but I don't feel like I need to do that right now. So we got 2 power supplies at 12 volts. Let's get it going on AC. What was I just about to do? Man. Totally, I was about to do something. It'll come back to me. So we're going to look. That's weird. Oh. Let's try this. it's amps. My bad. Thought it was volts. That's what we were gonna do. Alright, so the amps are nothing special, about 130 amps. Oh yeah, but that's AC amps. 253 DC amps. Wow. That's a lot fewer amps than the last time I did this. So about 250 milliamps is being generated, and about 220 volts on the downspin with the signal generator running things. But yeah, the last time I got it, and I got it on video, was 1.7 amps. So that's a lot less amps. That's cool. All right. Wow, that's going up. Now it's going down. So without any like drive power, we actually made it go up using this solid state device. The amount of AC voltage. I think that's pretty sweet. that's running on pure signal generator right now, actually. Is it gonna stop? Yeah, it's gonna stop. Pretty neat though, I think. Right. So that, see, we were just talking about oscillation, and you see now that the wheel is coming to a stop, and look at how much AC voltage is coming out of the system. right there is 420 volts. Alright, we're going to stick with our 4s across the board. So why am I doing this? Because it was suggested through telepathy to me that I should pulse my solid state device twice instead of just once. And you know what? It's a great idea. Phenomenal results. And now, with no further ado, we're going to charge this cap bank with the solid state device underneath the pulse motor. Alright, so that's how we're gonna close it out. I'm gonna hook this up. We are going to have a merry day. We're gonna have the day of our lives. Alright, we just need one more. Take this one. Okay, now, for good measure, we're going to hook up a multimeter to the cap bank. We're going to turn it on. Boom, boom. 10 volts, 0.33. So this meter now is going to show us a different wave than has been previously demonstrated. It's already starting to generate though for the cap bank. 1037. And there's our square wave. That is the wave that we are now generating because of the load that we put on. So this is a sine wave in and square wave out. But we are charging the cap bank at a pretty snazzy rate right now, and it's going pretty fast, in my opinion. And I've been doing this for a little bit. I don't know if I've been doing it exactly the right way. I mean, my mind has not yet officially been blown by anything. So, I just haven't been touching the right stuff, I guess. So cool. All right. And all this power, all the wheel does is set the frequency for the solid state. Sets a frequency for the solid state. You can see it's starting to spread out now. It looks different now. And we'll watch that as we, yeah, man, it's starting to spread out. It's awesome. And that's just with the load on there, so that's pretty cool. 1044. So we charged up about 15 tenths or 1500ths of a volt right there in the cab bank. It is a super cab bank, 500 farad, so 500,000 micro. Pretty neat, man. That's pretty cool. You can see the partition, and you can see, but when it stops, we'll be able to see whether it's going to charge without motion or not. So it's very curtailed. The wave is under a lot of magnetic interference right now. But if I move it like that, oh no, it's not doing anything. Hey, yeah, bye. That's pretty cool. I don't think it's probably generating, but you know, I'm gonna turn it off. I think that's awesome, man. I mean, everything that I'm doing right now is keeping me going, and that's pretty cool. I think I will try and set up a dual drive, dual closed loop system incorporating the cap banks. But we'll see what. Maybe I just need to put a diode on the negative terminal. Maybe that's what's lacking. Because the ground doesn't have a diode on it, on any drive. So, but we'll figure it out. All right. So thank you very much, ladies and gentlemen. Peace out. Have a wonderful night. Please subscribe. Bye now.